So this question is distribute money to maximum children. So this question is a little bit challenge. So what you should do is you want to distribute money to all of the children, and everyone receive $1, and nobody receive $4, and then return the maximum the number of children who can receive $8, exactly $8. So yeah, let's not worry about example. So let's think about it. Um, if everyone needs to receive $1, which means when you got the money, you need to distribute $1 to every children. So if this is money, money will be minus equal to children right away. So everyone will receive $1, which will satisfy this, right? And then the next one is going to be if this is the update money. I mean, this is the money that after I distribute $1 to every children. If this money is divided by 7 is equal to the children and also m multiplied by 7 is equal to 0, which means there is no remainder, and it's going to be equally distributed to all of the children, right? So we already have $1 right here, and then we have a remaining $7 right here. So this will return what, the $8, right? So you will return the children, the number of children right away. It's going to be exactly match. So think about this. So the money is 16, children is 2. So you distribute $8 for one child. So this will return what? 2 for the maximum, right? So yeah, 2 for the maximum. And then if you do the math, and then you can do, so on, right? So again, so this will be one scenario. Another scenario is this. So you're gonna have a C1, C2, C3, C4. So imagine you have $7. You initially you have $1 for each, and $7, $7, $7. And then at some point you're going to put the remainder dollars right here, but it will contradict right here. So imagine that they are $4 right here. So which means there will be a math. They calculate this, and this will be what? So it's gonna be money divided by children, and then that will be equal to the sorry, not divided by 7, not divided by children, but divided by 7. Money divided by 7 because 7 is right here, right? And then it's equal to the children minus 1, right? Children minus 1, and then you also want to consider money multiplied by 7 if this is equal to 3. So I'm not counting this. I'm not counting the first dollar. That I don't care. The money has been updated. So if this is equal to 3, technically you want to what? You want to share the last one. So imagine this is 6 only. You want to share the last one over here. So this will become 5 total, right? This is 8. And this is 8. So 8, 8. Technically this is 7. You need a plus 1 right here. So 7 and then 5. So you want to make sure you don't violate. You don't violate this constraint. Nobody received $4. In this case, it's going to be 2. So if this condition happen, you return children minus 2. All right, and the next condition is going to be like this. So if you have ton of money, so imagine you have infinite money, and then you have the number of child is going to be c to the 4. Okay, so what you can do is that you have 4 for C1, C2, C3, C4. Initially, you got $1 for each, and then you can stack 7 here, stack 7 here, stack 7 here, and then the remainder dollar will be stacked to the last guy, and then you will receive what? You'll return the maximum number, which is 3. So in this scenario, it's going to be children minus 1, but this is considered when you have too much money, right? And then another condition is going to be if you don't have too much money. If you have like $5, and then your number of children is 6. So again, actually this might not be a good idea, but all right. So it's okay. So C1, C2, all the way to C6. and then you can only distribute what? 5 of them. Then which will what? Break out the law, right? So in this time you will return -1, which is not fun. Alright, so in this one, let's update this one to 7. So 1, 2, 3, 4, 5, 6, and then there's an extra $1 you're gonna put over here. So if the money, so the leftover money, so 7 minus 6, right? The leftover is 1. If 1 divided by 7, if this cannot, if this amount of money cannot put at one person, then you will just return the division of this. Yeah, you need to think about it. That is not going to be easy to understand. So money minus the children, so I update the money. So if the money is less than 0, you will return -1. Else, if the money divided by 7, divided by 7 is equal to the children, and also money multiplied by 7 is equal to 0, which means you are distribute the money equally to everyone. So children, and then if the money divided by 7 is equal to the children minus 1, and money multiplied by 7 is equal to 3, which will validate this one. So you want to take another children away to distribute the money, so it's going to be children minus 2. This is the last one, the last person, and this is this is others children, and this is the last children, right? And then since you are validated the law, you want to use the second last to distribute the money to the last one. So the total children you can get, the maximum dollar is 8, which is going to be children minus 2. And then the last one is going to be either you have too much money or not enough money, right? So it's going to be children minus 1, and also money divided by 7. So this will be the solution. All right, so it's pretty good. It's pretty good. So time and space is going to be constant. And then in this solution, you can definitely, so think about this. You can definitely use the while loop to traverse and then divide by 7 every single time, and then keep track of the how many number of children you have, right? So in this one, it's better. If you want to use in the while loop and then the money goes beyond the boundary, so you imagine like 100 million or 200, something like this, and this will cost in the TLE. But if you do this, it's actually pretty straightforward. So this is my solution. All right, see you.